Welcome to the channel, folks. Today I'm doing differentiation by rules. But before we start, I just want to point out this important factor or condition. It says if a function f of x is given as ax to power n, then the derivative of this function with respect to x is an x to power n minus 1. What happened here? When you differentiate this, you take the exponent to the variable, you multiply it with the numerical coefficient of the variable. Then you subtract 1 from the exponent. Let's see what I'm talking about. The exponent was n. I multiply the numerical coefficient of x, which was a, by n. I go to the exponent, I subtract 1. Now I have differentiated f with respect to x. What does this answer tells us? This tells us the gradient everywhere in this smooth continuous function. We refer to it as the gradient function of that function. In every point here, the gradient is equals to this. Now, folks, another thing, when you differentiate any given function, make it a point that it is written in this form. Now, let's go to the example so that we demonstrate what we are talking about. In my example, I'm saying to you, determine the derivative of the function y with respect to x if it is given that y is equals to 2x to power 5 plus 4 divided by x to power 3. Now let's look at this given function. Can you see that 2x to power 5 is in that form? But can you see that 4 divided by x to power 3 is not in that form? Now that means we cannot, according to that, differentiate this one. This must be written in that form. Now, let's move on to the solutions so that we demonstrate what we are talking about. Look at this now. Step number 2. Here, I copied down the given function. Now, because I could not differentiate this, I had to write it in this form. This is what I did. Using what I know from the exponents, that if I have a to power minus n, that is exactly equals to 1 divided by a to power n. Now, if I have 1 divided by a to power n, that means I have a to power minus n. In this case, 4 divided by x to power 3 is the same as 4 multiplied by 1 divided by x to power 3, which is x to power minus 3 multiplied by 4. Now, if you look at this, I have managed to write this in this form. Now, that means that I can now differentiate. Folks, please look at this. In this step, I copied down the given statement or function. Here, I rectified that so that I can be able to differentiate. If you look at how I write it, I am actually showing that I have not differentiated. The function is still y. Now, next step, I'm going to differentiate. Now I'm differentiating the function y with respect to x. I multiply 5 by 2, which is 10. I subtract 1 from 5, which is 4. I multiply negative 3 by positive 4, which is minus 12. I subtract 1 from minus 3, which is minus 4. Now, I have differentiated this function with respect to x here. That means this is the gradient everywhere in that particular function. But now, the last step, I always encourage my learners to give exponents as positive. Your final answer must have positive exponents. Now, what I did is I did exactly that there. Therefore, the derivative of y with respect to x is equals to 10x to power 4, which is what I got there. Then I wrote x to power minus 4 as a positive exponent. This is the perfect answer. We shall have differentiated the given function. Next problem. We are still differentiating the function y with respect to x. The function is now y is equals to square root x minus x to power 2 all raised to power 2. Now, remember that in the rules for differentiation, we said when you have a product, before you differentiate, make it a point that you multiply the two. Then you differentiate the answer, which is the product. Let us look at what I'm talking about here. The function is y is equals to open bracket square root of x minus x squared close bracket raised to power 2. Now, remember, before I differentiate this, I must multiply the two brackets. I can only differentiate the product of that. Now, let's multiply them. If you multiply the two brackets, square root x multiplied by square root x is square root x squared, which is equals to x. Square root x multiplied by minus x squared is minus x squared square root x. Minus x squared multiplied by square root x is minus x squared square root x. And remember the two, this one and the product of that, and this and its product is actually like terms. That would give us minus 2x squared root of x. You multiply this by that, you get plus x to power 4. Then from there now, you can see that this is written in a differentiable form, and we can also differentiate that one. The problem is this one. It would mean that we need to write this in a correct form. Now, what is the correct form? Remember, square root x means x to power half. Now, that means that this is 2x to power 2 multiplied by x to power half. We need to simplify that. Remember, when we multiply powers with the same base, we add exponents. 2 plus half is 2.5, which is 5 divided by 2. Now, if you look at this function, it has been simplified it can now be differentiated. You look at how I wrote that. There's nowhere where I am implying that I have differentiated, whereas I did not. Now, I'm differentiating. Differentiating the derivative of the function y with respect to x is, I multiply 4 by 1, which is 4. I subtract 1, I get 3. It is 4x to power 3. Come to this one, I multiply 5 halves by 2, I get 5. Remember, the 2 was negative, it would be minus 5. I subtract 1 from 5 halves, and I get 3 halves. I multiply 1 by 1, I get 1. I subtract 1 from 1, I get 0. X to power 0 is 1, and 1 times 1 is 1. Now, I can write x to power 3 halves in a set form. This answer and this answer exactly mean the same thing. I can write this as 5 square root x to power 3, which is that. But now, each one of them is acceptable. Don't worry about changing from this to that or changing from this to that in the final answer, because each one of them is acceptable. We have differentiated the given function with respect to the variable x. Lastly, be very careful of this notation. We have to differentiate this function with respect to x. It says differentiate this with respect to x. Let's do that. Now, you need to remember that before you differentiate, if you have more than one bracket and you are multiplying, you need to find the product first, which is what I'm going to do here. Now, I want you to forget about this side a bit. Let's put that there. Now, we multiply. I haven't differentiated. Please note that, folks. I have not started differentiating here. I'm just multiplying. X squared multiplied by x is x to power 3. X squared multiplied by plus 3 is plus 3x squared. Then I multiply minus 4 by plus x, which is minus 4x. I multiply negative 4 by 3, which is minus 12. Now, I can now differentiate. And please note this. In this one, when I differentiate, I indicate it with this equal sign. This equal sign means that now I am differentiating this function with respect to x. Let's do that. It would be 3 times 1, which is 3. I go there, I subtract 1, which is 2. The derivative of x to power 3 is 3x squared. We come to this one, the derivative of 3x squared is 6x, because it is 2 times 3, which is 6, 2 minus 1, which is 1, that is x to power 1. The derivative of minus 4x is a minus 4. Remember, there's a 1 there. 1 times minus 4 is minus 4. Then I have got a plus 1. Plus 1 minus 1 is 0. And x to power 0 is 1. Minus 4 times 1 is minus 4. The derivative of a constant is always 0. That is why there I've got nothing. The derivative of minus 12 is equals to 0. We have differentiated this function with respect to x there. And how do I know that it has been differentiated? Once I see the equal sign, I know that it means that now we are differentiating, or we have differentiated. Folks, I hope that you will understand this, because these are free marks. And remember that the derivative of any function tells you the gradient function in that particular given function. Thank you very much. Thank you for watching the video, and please subscribe to the channel. Turn on your notification for new informative videos. Remember to always practice your mathematics for proficiency. And if you want to be procedural fluent, watch the videos and practice.